In this video, you'll learn how to design a double split shaft clamp in AutoCAD, which consists of 4 components. Hi again, I'm Milad, and I'm back with another AutoCAD 2026 tutorial. In this video, as you can see on the screen, I'm going to teach you how to model a double split shaft clamp with the specifications shown here. This clamp consists of 4 separate parts. As always, I start by setting the units using the unit command, since I'm going to work in millimeter dimensions. Using the circle command, I draw 3 circles, the first with a radius of 10 mm, the second with a radius of 20 mm, and the third, which is just a construction guide, with a radius of 23.2 mm. The clamp I'm designing is a double split clamp collar, used to hold, position, or secure components on shafts. It's made of 2 halves and tightens around the shaft evenly when screws are applied without causing any damage. Next, I use the extrude command to extend the circles to a length of 150 mm to form a 3D volume. To subtract the smaller circle from the larger one, I use the subtract command. Then, I draw a construction line to mark the centre of the screw hole. This line is at a height of 7.5 mm from the base, right at the centre, and located 150 mm from the clamp's centre. Now it's time to design the screws. First, using the circle command, I draw a circle with a radius of 3 mm and extrude it 21 mm to create a cylinder. I repeat the process for the screw head, but this time the diameter is around 8.613 mm. I extrude this part to a height of 11.9011 mm. I changed the visual style to conceptual so the view becomes clearer. Then, using the rectang command, I create a rectangle that's 0.5 mm thick and wider than the clamp diameter. I extrude this rectangle beyond the shaft's height. Using subtract, I can now split the shaft into 2 separate pieces. I switch the view back to 2D so I can see the details more precisely. Next, I start drawing the thread around the screw using the helix command. This helix has a radius of 6 mm and a pitch of 1 mm. The helix command in AutoCAD is used to draw 3D spiral curves like threads or springs. You can adjust base diameter, top diameter, pitch and height with it. Now I need to create the profile of the thread. I use the circle command to draw a small circle with a radius of 0.25 mm. This circle needs to be perpendicular to the thread path, which I do using the 3D-rotate command. I've shown this process before in the Allen screw tutorial. You can find that video right here on this channel. I convert the circle into a region using the region command. This command is used to turn closed 2D shapes like polygons or circles into regions that can be calculated and used for 3D operations. Using the sweep command, I extend the drawn circle along the helical path to create the thread. Then, I rotate the screw to align it with the clamp. I make a copy of the screw to use as the main one later. I drag and move the screw into its correct position on the clamp using the Move command. Make sure to check the alignment from different angles to get it right. Socket head cap screws have cylindrical heads with internal hex sockets that are tightened using an Allen wrench. These are commonly used in tight spaces and precision applications like assembling mechanical parts and machinery. To create a mirrored copy of the screw on the other side of the clamp, I use the Mirror 3D command. I select 3 points on the center plane so the screw is mirrored accurately. Using Subtract, I remove the volume of both screws from the clamp to create the holes and threads. You can view the result from different angles. Now, back to the screw for some fine-tuning. First, I subtract the helix from the screw body using Subtract to cut the thread into it. The screw is taller than the standard size, so I reduce its height. I do this using a cylinder that's larger than the screw, place it over the top and subtract it from the screw. The top also needs to be trimmed, so I do that down to a specific height. Next, I need to create the hex socket where the Allen wrench fits. For this, I use the Polygon command. With the Polygon command, you can easily draw regular shapes like hexagons. Just type Polygon, hit enter 6 for the number of sides, then choose whether you want it inscribed in a circle or circumscribed around 1, and give the radius. AutoCAD draws it perfectly. This command is very useful for geometric designs and saves a lot of time. I use Extrude to turn the hex shape into a 3D solid. Then I subtract it from the top of the screw to create the hex socket. Next, I run the Union command to combine all the parts of the screw into one solid body. Now I move the finished screw into its position. To create another screw on the opposite side, I use Mirror 3D again. The Mirror 3D command in AutoCAD lets you mirror 3D objects across a defined plane. Just pick 3 points to define the mirror plane, and AutoCAD reflects the shape accordingly. It'll also ask if you want to keep or delete the original. It's great for fast and precise 3D modelling. Now I'll round off the edges of the screw slightly using the Fillet Edge command. And that's it. The clamp is complete and ready for use. Take a look from different angles. And don't forget to subscribe to my channel for more AutoCAD tutorials.